Bismillahirrahmanirrahim. Today we are going to study about the Laplace transformation. So first we define Laplace transformation. Let f of t be a well-defined function of t for all positive values of t. Then the definite integral 0 to infinity e to the power minus of st ft dt, if it exists, is called the Laplace transformation of ft, and we write capital L square bracket ft is equal to fs bar is equal to 0 to infinity e to the power minus of st ft dt, where s is a dummy parameter. We can also write ft is equal to L inverse fs bar. Here ft is called the inverse Laplace transform of fs bar. Some well-known transform theorem and formula. First, linearity theorem. Laplace transformation is a linear transformation, that is, if L f1t is equal to f1s bar and L f2t is equal to f2s bar, then for any constant c1 and c2, L square bracket c1 f1t plus c2 f2t square bracket close is equal to c1 f1 s bar plus c2 f2 s bar. Now first, shifting theorem. If LFT is equal to fs bar, then L e to the power at ft is equal to f s minus a whole bar. Now there are some formulas. So first formula is L e to the power at is equal to 1 by s minus a, where s is greater than a. If we take a is equal to 0, we have L1 is equal to 1 by s. Second, L cos of at is equal to s over s square plus a square, and L sin of at is equal to a over s square plus a square. L cosine hyperbolic at is equal to s over s square minus a square, and L sin hyperbolic at is equal to a over s square minus a square. Next, L t to the power n is equal to gamma n plus 1 over s to the power n plus 1 is equal to factorial n over s to the power n plus 1 if n is a positive integer. Making use of first shifting theorem, we can write few more results as L e to the power at t to the power n is equal to gamma n plus 1 over s minus a to the power n plus 1. L e to the power at sin bt is equal to b over s minus a whole square plus b square, comma L e to the power at cosine of bt is equal to s minus a over s minus a whole square plus b square. L e to the power at sine of hyperbolic bt is equal to b over s minus a whole square minus b square, comma, L of e to the power at cosine hyperbolic bt is equal to s minus a over s minus a whole square minus b square. Now properties of Laplace transformation. First property, change of scale. So if LFT is equal to Fs bar, then LFAT is equal to 1 by A F bar S minus S over A. Second, multiplication by T. LTFT is equal to minus D over ds Fs bar. LTFT is equal to minus D over ds Fs bar. In general, L t to the power n ft is equal to minus 1 to the power n dn over s ds to the power n fs bar. Third one, division by t. L 1 by t ft is equal to s to infinity fs bar ds. Fourth one, Laplace theorem of derivatives. L fn t, fn means differentiation of n times with respect to t of ft. So L fn t is equal to s to the power n f bar s minus s to the power n minus 1 f0 minus s to the power n minus 2 f dash 0 up to minus f to the power n minus 1 0. And fifth one, Laplace transformation of integrals. So if L ft is equal to fs bar, then L 0 to t fu du is equal to 1 by s fs bar. Now we are going to solve some examples. So first example is L sine square t. So we don't know till now any formula directly to solve L sine square t. So first we change sine square t in terms of without power, I mean like 1 minus cosine of 2t over 2. So taking L sine square t is equal to L 1 minus cosine 2t over 2. This is equal to L 1 by 2 minus 1 by 2 L cosine of 2t. This is equal to 1 by 2s minus s over 2s square plus 4. This is equal to 2 over s square plus 4. Answer. Now second question, L sine 2t cosine 3t. We also do not know directly find the Laplace of two product of function of two product product of two functions so we will use the trigonometric formulas. After using the formula, we get L sine 2t cosine 3t is equal to 1 by 2 L sine of 5t minus sine of t. and we know the formula L of sin t at, so we can write 1 by 2 5 by s square plus 2 25 minus 1 by s square plus 1. This is equal to 2 s square minus 5 over s square plus 25 and s square plus 1. Now we are going to take the another one example, L cosine cube t, which is equal to 1 by 4 L 3 cosine t plus cosine 3t. This is equal to 3 by 4 into s over s square plus 1 by 4 s over s square plus 9. This is equal to s square plus 7 divided by s square plus 1 into s square plus 9. Now another example, L of e to the power minus of 2t into 3 cosine of 4t minus 2 sine 5t. This is equal to, we will separate the term. So 3L e to the power minus of 2t cosine of 4t, because 3 is constant so it will come outside, and in the second term 2 is constant so it will also come outside, minus 2L e to the power minus of 2t sine 5t. So according to the formula, this will be 3 into s plus 2 by s plus 2 square plus 4 square minus 2 5 over s plus 2 square plus 5 square. This is equal to 3 s plus 2 over s plus 2 whole square plus 16 minus 10 over s plus 2 whole square plus 25. Now second example, L sine hyperbolic at into cosine at is equal to L 1 by 2 e to the power at minus e to the power minus of at into cos a cosine of at is equal to 1 by 2 L e to the power at cosine of at minus 1 by 2 L e to the power minus of at is cosine of at. So according to the formula, Laplace formula, 1 by 2 s minus a over s minus a whole square plus a square minus 1 by 2 s plus a over s plus a whole square plus a square. This will be the required answer. Now the third example, t sine a t sine at is equal to minus of d over ds L sine a t. This is equal to minus d over ds a over s square plus a square. This is equal to, after differentiation we get 2as over s square plus a square. Now the fourth one, L t cosine of at, this is equal to minus d over ds L cosine at, this is equal to minus d over ds s over s square plus a square. So after differentiation we get s square minus a square over s square plus a square whole square. Now we solved some more examples, which is example number 1, L sine of at sine of bt is equal to 1 by 2 L cosine of a minus b into t minus 1 by 2 L cosine a plus b into t. So according to the Laplace formula, 1 by 2 s over s square plus a minus b whole square minus 1 by 2 s over s square plus a plus b whole square, or L sine AT sine BT is equal to 2abs over s square plus a minus b whole square into s square plus a plus b whole square. This will be the required answer. Now the second, we know that if LFT is equal to Fs bar, then Lt to the power n Ft is equal to minus 1 to the power n dn over ds to the power n Fs bar. So Lt to the power n e to the power minus of 2t is equal to minus 1 to 1 square d2 over ds square of 1 by s plus 2. This is equal to 2 over s plus 2 whole cube. Thus, L t square e to the power minus of 2t is equal to 2 over s plus 2 whole cube is the required answer. Now the next, we know that L e to the power at sine bt is equal to b over s minus a whole square plus b square. Therefore, L e to the power minus of t sine t is equal to 1 over s plus 1 whole square plus 1. Since L is L of 1 by t ft is equal to s to infinity fs bar ds, where lft is equal to fs bar, then L of 1 by t e to the power minus t sine t is equal to s to infinity ds over 1 plus s plus 1 whole square plus 1. This is equal to tan inverse s plus 1 s to infinity. This is equal to pi by 2 minus tan inverse s plus 1. This is equal to cot inverse s plus 1. We know that L of e to the power minus of t sine 3t is equal to 3 by s plus 1 whole square plus 9. So therefore Lt e to the power minus t sine 3t is equal to minus 1 d over ds 3 over s square plus 2s plus 10, and which is after differentiating we get 6 s plus 1 over s square plus 2s plus 10 whole square, which is the required solution.